I'm George Landis from Landis Performance Center and Racer Supply Store. We hope you're enjoying our videos. Please click the subscribe button so you can see our videos are easy to find. If you want to see when we upload a new video, click the bell and it will notify you whenever we install a new video. And please click the comments and leave a message or a question. We'd like to know what you're thinking about, what you'd like to see in the future, so we can help bring more content that is interested to you. We want to make it a community that everybody can enjoy. Thank you for watching. Enjoy the video. Okay, so I'm going to show you some tips and some navigation tricks for the Accel DFI Gen 7. It's quite a antiquated system, but very efficient in its performance, and I still get quite a few calls about this system. Okay, so one of the first things we're going to do is go back to the properties, and I'll show you how to run this system on a newer computer. This software was actually designed for Windows XP, which obviously is old. So we get the icon on the computer, you can right click on it, click on properties, and then click on compatibility. Let me drag this over here to the center. And as you see, check mark compatibility mode, and then you can select any of these systems and the computer will operate like it is that computer. So on my computer I have it set up as a Windows 98, and now all the functions of my Windows 10 are going to be the same as a Windows 98 when operating in this software. So we're just going to click apply and OK. So now we can go back and open the software. Click yes to run it. Okay, now being this is on my desktop and not connected to a vehicle, we have to go offline. One of the things that you'll find when you're going online, you see here, it says right click for COM port options. This software will not work as a plug and play, so you can't just connect your USB port to the car and have it communicate. So if you're going to connect to the vehicle, you have to right click and then tell it which COM port you're using for your USB to serial adapter. It will not do it on its own. Once you do this on your computer, you don't have to do it again unless you plug another device into that same COM port. Then you will have to do this all over again. So we're going to go offline and we're going to pick a file. Pick this 383 file. And here's the operating system. So what you would want to first do when you're putting a file in your car, going to config, well, the first thing you want to do putting a file in your car is go to File and then program a global calibration from a file, and then that would install a file like if I sent you one or if somebody else sent you a pre-written file. Then you'd want to go to configuration and go to setup, or system rather, and now you have the basic commands of the vehicle. First thing you want to do is ignition type, and now you have to pick what type of ignition you're using. These are the ones that are already set up for you in this. Most of the time you're going to have to use something that's already here. You can do some custom stuff with some Hall triggers, and we can get into that later. So we'll just go ahead and pick DFI dual sync. Now in this software, whenever you change anything on a table that looks like this, you have to click F10 to send it to the ECU, or click send all, but I prefer to do one at a time. So since we've made a change here, click F10, it says data transfer, and you know it's good. Now the other thing is anything in this box here, you will have to key off and key on before it becomes functionable. The reason they did that is somebody's trying to tune while driving the car, and they by mistake change an ignition parameter, the car would shut off. So they made it so you have to physically turn the car off and turn it back on before this would happen. So just go through these cylinders, displacement, ignition delay. Ignition delay is the amount of time from when the trigger is seen by the ECU and the signal goes to the ignition box and then to the spark plug. So the way you would know if you needed to adjust this is you would go back to our main screen and we would force timing. We will put 25 degrees. Now you would put a timing light on the engine and rev it up at least to halfway to red line. If the timing stays at 25, our forced number, then the ignition number is good. The ignition delay number is good. If it skews low or high, then you have to adjust this accordingly. Again, click F10 before you make a change. Also, if your distributor does not have a phasable rotor and you're checking the phasing on your rotor by drilling a hole in your distributor cap and using a timing light on that wire to see if the rotor is lined up, you can use crank index offset to adapt for that. So if you're using a GM HEI, you would have to put 6 degrees of offset because the rotor is built in with 6 degrees of advance in the distributor the way it's designed. So you would use that to calibrate your rotor or phase your rotor properly. Another key note is anything on these screens, you can get to the instruction booklet for that part. So if we go back to our ignition delay, we click that and then click F1, and there is our information on how to make those adjustments. And that is for anything in this software. You can do that on any page. And alternate F1 will take you to the wiring schematics. There's a complete master schematic, and then you've got a drop down with individual schematics. So I'd say like F-body HEI adapter harness, and there it gives you the description and the pin locations of either how to build your own harness or at least to check to make sure your harness is correct or whatnot. Okay, so being that this system is a VE system designed by OE engineers back in the day, Ford engineers actually, a couple things have to be put in correctly. Your displacement needs to be correct, your injector flow rate needs to be correct, and your fuel rail pressure needs to be correct. And the reason being is that these bits of information go in to make up the pulse width. So if we go out of here and go back to go to our base volumetric efficiency, these numbers are just a relative number. It's not nothing to do with pulse width or duty cycle. It's the amount of air theoretically is going in the engine, i.e. 1.000 would be 100% volumetric efficiency. Not sure exactly how accurate that is, but that is the way that it was designed. If you wanted to see your pulse width or duty cycle, go down to pulse with Estimator, and you see it needs an intake air temp. Again, there are several adder tables in the background to come to that last number. So we'll put 75 degrees, use that value, and now it's generated a pulse width. It's adjusted the VE numbers to a pulse width. And if you see the corner is red, that's because it's over 100% duty cycle. If we slide the bar to duty cycle, you can see there that it's overshot the injector size by quite a lot. And for the people that were tuning back in the 90s, if you were used to a old Silverbox 6.0 cal map, there's you have to change it to stagger batch, but those would be the numbers there. Actually, let's do that. So here's our fueling type. We're going to change it to staggered batch. Again, hit F10. Now we'll go back, hit F2, and now we'll go back to our estimator. 75 degrees. And there's our numbers for a 6.0 map. Also look very similar to the FAST system, because the FAST platform was designed by John Meany, who actually designed the 6.0 cal map on the older systems, and those are the kind of numbers that they used to determine pulse width. Okay. Couple other things. This system has diagnostics. It will trigger a check engine light, so we did that for California emissions or any other states that have emissions that require a check engine light to turn on. So under diagnostic, you got engine sensor monitor, and this will give you what's going on with all the data points live while the engine is running. You can go to status and diagnostic, and this is really good for a vehicle that doesn't start, because right here you have cam sensor and crank sensor and tooth count. While you're rotating the engine, you should see if you have crank only, you should see this crank. It's a simulated LED. It will blink. If it's not blinking, you're not getting a signal from your distributor. And likewise, if you have a dual sync, your cam should also blink. If not, then it's not working. Gives you a quick way of telling where you need to go to figure it out. And we have error code list. If you have error codes, it will go here. Some of them you can disable, some you can't. You can also view the list of codes, and that basically gives you what each code stands for and what it will default to. Very helpful when you're not, when the vehicle's not running and you're trying to figure out what it's doing. Go back to the main screen. And here you'll see you have quick keys. There's help, VE, Spark, AFR, and so forth. Data logging, and all those all are quick settings to go to where you need to go to help you run from page to page, or you can use the simple drop downs that are up in the top. You got simple ones like this. Okay, so let's just go over a couple different pages, and I can show you where the adjustments are. A lot of people seem to not see the adjustment instructions on the screen, so we're going to go over it. So let's go to V2, F2, which is your VE, and here's your VE table, RPM across the top, trim or map across the side, and this screen is in PSI. You can scale this back into configuration any way you want to. One of the key things to know is when you're doing data logging, your data logging map information needs to match. So if this is in PSI, you need to data log in PSI. Otherwise, they will not overlay. So as far as adjustments on the page, here's all the things that the screen can do. You can press this key on your keyboard and it changes the cell value. You can, that's up and down, up, or, yeah. And then if you want to multiply, you can use that. So say you want to multiply this screen, you can hit the, as it says, X key, and now you can multiply that cell by a certain number. 1.00 means 0 adjustment. So 0.90 would be 10% down. 1.1% would be 10% up. If you wanted to fix, say you've got a hiccup in your map and you want to smooth the numbers out, you can do a block or a row, hit the I key, and it'll interpolate those together, so it'll smooth them out for you. You'd want to click enter when you're done to make the adjustment stick. If you want to increase or decrease the rate of change, you would use the /. Shift and arrow selects the keys. If you don't want to use your mouse, you can select and use your arrows and go down any way you want to go. T will toggle the tracer mode. U will clear the tracer mode. Enter sends the changes to the ECU. Space, select current operating point, and Control Z undoes the last operation. These are very easy ways of making adjustments on the screen, and they will hold true to all tables that look like this. Same adjustments. You can see your 3D image of the screen. You can see that's pretty bumpy. You can actually use your bar keys and adjust while you're here. Then use your arrow keys to move, so you're trying to smooth it out, you can do so. Gives you a good, easy way of seeing where you're at. You can also pull a section like that, hit your eye, and it'll do the same thing. Okay, so that's volumetric efficiency. This is your timing, but because it's forced, they gray out the screen to remind you, hey, it's forced timing. We can unclick the force. Now we're back to an actual table that is controlled by the ECU. F4 will take you to your VE, or to your air fuel table. And all of these adjustments that we went over are the same on all three of these screens. So you load a file, somebody sends you a file, you make a file, whichever it is. You're at your main screen. There's a couple things you want to do when you first start the vehicle. First, calibrate TPS. So to calibrate TPS, you're going to let it sit at its idle point, store the low point, hold the throttle to the floor, set your high point. Now your TPS, you should be able to sweep your TPS and it should go 0 to 100%. If it goes backwards, your TPS is wired backwards. And if it has a break in it, if you go slowly, you can see the numbers get goofy. Instead of going up or down in a exponential number and there's gaps, well, then you'll see that you have a bad TPS sensor. Little tidbit. The second thing you want to do once you get ready to start the car, again, is force timing. Put a number in. I usually use between 20 and 25 because that way no matter where the timing is at, it's going to still maintain an idle. Now you would go out to your engine, put a timing light on it, and calibrate it. If the timing light on the balancer shows 15 degrees, you need to advance the distributor till it reads 25. The end result is you want the timing in the computer and the timing on the engine to match. That way the numbers in your base timing table are accurate numbers. Then from there you would go ahead and start tuning your engine. Now, one little thing here is if you're going to send a data file to somebody to have them look at your file to see, to do tuning changes or whatnot. As I said, this PSI is what we need. Since this scale is scaled to PSI, when we go data logging, we're going to configure. Here's our 6 channels that we can data log. engine speed is always number one. Map, you can see it's in percentage. That's going to mean nothing to whoever's looking at the data. It's not going to match your map sensor, so it's not going to work. So you need to hit the drop down box and find the map that follows what your VE is set at. This one is set at PSI, so we click map PSI. Click OK. And then I myself like to record actual and then change the O2 feedback, which is going to give you a percentage or a correction value. I'd rather see actual or a target because we already have actual. So we click target. Now our data record is going to show actual versus TPS. Degrees of timing is good, and throttle position is very important. The reason being is transient TPS readings. In other words, you're tipping into the throttle or tipping out of the throttle. Should not be tuned until your base fuel map is completely tuned. Again, that all your accelerators, your cold starts, those are all adders. So if the main table isn't right, they won't be right. So don't mess with them until you get the main table tuned. So we want to be able to read the data when the TPS is at a fixed position. Then we can do that. You can save that configuration. I usually put that as base fuel. And now whenever you come back to it, you can just load base fuel and all the adjustments are already set for you, because when you click out of this and come back, it will change back to the main one. You can click monitor, and if the engine was running, you would see the bar graph going across giving you information. Click record to make a recording. You can click options to either make a manual where you click the record button, or you can do it automatic where you can set it by TPS, engine RPM, whatever you want to do. We go to automatic, variable 1, greater than. So there's our variable 1, engine RPM. So greater than 3,000 RPM, it'll start recording. We can then do a and or a or if we want to finite the adjustment even farther. But we typically just use manual. And you can change your sample rate and your file length. Sample rate 10 samples per second is usually good, and I will usually make a data recording 60 to 120 seconds long. That way you can see a good bit of good information. Click OK. If you click save again to the same name, then it will hold all those adjustments for you. So once you do a data log, it'll time out. Once it times out, it'll ask you what to do with it. I usually just click on analyze and save. It puts it tags it with a timestamp off of your computer's clock, and it makes it easy to figure out which one was the last one you did and whatnot. You can rename them if you want. Now, a couple of things. We go to analyze data. We can go to a graph data, and let's pick this one here. And there's a data log, what it looks like when you do a recording. This is when the car has been driven. You can see the red is RPM. There's a shift. White is TPS. We can see the TPS was constant. Now this one was done in O2 correction, so all it tells us it was taking out 4% fuel, and you can use it that way, or I prefer to have the target over top of it, and you can see what's going on. Now the other way you can view a data log is go to fuel analysis. Now, with the TPS, with the map sensor being set properly, you can see where the data log was throughout through the VE table. Here you can see speed, you can map, actual. These are all the numbers that were in, all the variables that were in your data record. And as it says here, you can page up or down to advance the curve. So we can go through here and you can watch the numbers. Here's time, the data point, total points, and you can see where it's at. So you get here and you go, let's go back. Oh, there it was lean. Now you could make an adjustment there. Typically what I would do is look at the whole data log in a whole and then try to make an adjustment off of that. But that's how it's done. When you get done making a tune change, you want to save the global calibration to a file. This is going to put what's in your ECU into a file. And what I would typically do is not click the file that's entered automatically. I usually will go through, and as you can see here, I've got a tune number, what was done, and I've got the date. It just helps me keep track of the tune so I know what's going on with the vehicle. And I've got this one set up 383 L98 engine, 120 pound injectors, 3 bar, 50 psi, E85. And that gives me all my information on what that tune was, so I can go back to it if I want, plus the date of when it occurred. And as I said at the end, it's got a change. 4% fuel was added to the tune. And then you could save it, and then you would be able to go back and forth. You always want to save your original file and then build off of it, and don't overwrite it. That way you can always go back if you make an adjustment and you don't like what happened. That was the first of a series of tutorials I'm going to do on the Accel DFI. I know it's an old system, but as I said, I get calls probably 2 a week that people are still using it. As long as the ECU is working, it's a great system. The newer Holley systems are obviously far better, just with any kind of electronics. This system was designed in 1999, so you can imagine 22 years ago, look how much change our laptops have gone. Even our cell phones. In 1999 we had bricks. Now we have phones that have computers in them. So the information I hope is useful. People can help tune their own vehicles, and you can always contact me for more information. I have software. I have a lot of the original engineering drawings on the wiring schematics and the harnesses. I can build harnesses if somebody needed. One of the things that is not going to be able to be had is a communication cable or a pro key. They haven't been made in years. The only way to get one is to find one used. One tidbit there is that when you're offline, you have access to everything. You only lose the access privileges to the pro and the sportsman when the car, your laptop is connected to the car and you're online. Then it will go refer back to whatever key was programmed in your communication cable, which most were sportsman level. Some were light. Light will only allow you to adjust idle and timing. So you can still make all those adjustments with a light cable. You just have to go offline, make the corrections, upload the new file, and then see if the correction was any good or not. Makes it a little time consuming, but it will work for you. So don't get hung up on the pro key, sportsman key thing. So that's it for now. I will post some more videos here in the next few days or week. Thank you.